So here in our last example, we're going to use differentials now to approximate tangent of 33 degrees. So if I'm going to use differentials, I'm going to start with my connection. Delta y over delta x is approximately dy dx. So that is delta y is approximately dy dx delta x. Dy dx is f prime of x. So now delta x, remember, is f of x plus delta x minus f of x is approximately f prime of x delta x. And then if I'm going to approximate, it's f of x plus delta x is approximately f of x plus f prime of x delta x. Now, yes, could I memorize this? Of course. But showing these steps, you could probably get this down to 1, 2, 3 steps. Shows me that you understand that you're using a differential and not just a linear approximation, your tangent line. So now I'm going to figure out what are my parts. So my function, f of x, is tangent x. The x value that I'm going to use close to 33 is x equals 30 degrees, which is pi over 6 in radians. And then what is delta x? Delta x is 3 degrees, which is pi, or 3 pi over 180, pi over 60 radians. So now I know I can find f of 30 plus 3, which is 33, using this differential approximation. So here I need f prime of x. F prime of x is secant squared x. F prime of pi over 6 is, we learned in our previous problem, is 4/3. So now I can find f of pi over 6, which is tangent of pi over 6, which is square root 3 over 3. You probably should have done that first. But f of x plus delta x is tangent of 30 plus 3 degrees is approximately f of x, which is square root 3 over 3, plus f prime of x, 4/3, times delta x, pi over 60. So that simplifies to be tangent of 33 is approximately square root 3 over 3, plus pi over 45, which we already checked previously is the appropriate approximation.